In this video, you're going to learn about linear functions. So what is a linear function? A linear function is a function whose graph is a straight line. It can be written in the form f of x is equal to mx plus b or ax plus by is equal to c. Now, the function notation, f of x, read as f of x. Take note, it's not f times x, okay? So f of x is the same as y, which means that if we have y is equal to x plus 3, we can write that as f of x is equal to x plus 3. Now, in f of x is equal to x plus 3, that f of x is what we call the name of the function. So we can use also other letters like g of x, or h of x. Now, that x is what we call the input or what we call the domain. And then this one, the x plus 3 here is what we call the function rule. Function rule means tells us what we're going to do, the process. And then that is, if we're going to simplify or perform the function rule, the output is what we call the range, or the result is what we call the range or output. Now, as what I said a while ago, that linear function can be written in the form f of x is equal to mx plus b, and that is what we call the slope-intercept form. The m there is what we call the slope, and b is what we call the y-intercept. Now, if I have f of x is equal to 3x plus 4, m or the slope is 3, and b or the y-intercept is 4. And if I have f of x is equal to 3/4 x minus 5, I have slope is equal to 3/4 and b is equal to, or the y-intercept is equal to -5. What do you mean by y-intercept? The y-intercept means is the point or the value of y wherein the graph crosses the y-axis. Now, another form is the ax plus by is equal to c, which is known as the standard form. If I have x plus y is equal to 7, a is the numerical coefficient of x, and that is 1. And b is the numerical coefficient of y, that is 1. And the constant c is equal to 7. Then, if I have 2x minus 3y is equal to 12, a is 2, b is -3, and c is equal to 12. Now, as what I've said also, that a linear function has a graph of a straight line. So I'm going to show to you the graphs of a linear function. So I have here, this is one of the graph of linear function. The graph rises to the right. And I have also here, it falls to the left, or I mean it falls to the right, rises to the left. And then I have also here just a horizontal line. And I have here another one, another graph. Now, let's talk about the domain and range of a linear function. Domain is the set of all possible x values, or what we call the input, and range is the set of all possible y values, or what we call the output. Now, the domain of a linear function is the set of all real numbers. So if it is the set of all real numbers, it means that we can write that in interval notation as parentheses from -infinity up to +infinity. Why? Because it covers all the positive and negative numbers. The range of a linear function is also the set of all real numbers, so therefore we can write that in interval notation as negative from -infinity up to +infinity. Now, let's check that. So look at this one. So this is the graph of a linear function. It's a straight line. And if you notice that this arrowhead, the arrowhead means extended, right? So it means that if we're going to continue this line, so the value of x here will extend also to the right, same as the value of y going up. So from here to positive and here to positive also, up to positive infinity, up to positive infinity for x. And that is the domain. This is the range, the y values. So same here, the graph going down. So it means the values of x here also decreases here. So as we continue this line, of course, it will continue up to negative infinity, the same as the value of y up to negative infinity. Now, why is it that these are not graph of a linear function? So I have here a vertical line. This is also a straight line, but it's vertical. Why it's not? Because look at this one. This is x. The graph crosses the x-axis at 1, 2, 3, negative 3. So what are the points now? If we are going to locate this point, that is negative 3, 0. If we're going to locate this point, that is again negative 3, 3. Okay? So 1, 0, 1, 2. Sorry, that is 2. Now, if we're going to locate this point, again, the x value is negative 3, and that is 3 as y. So you notice the x values here are being repeated, so therefore it's not a function. So once the value of x paired with values of y, so there are 3 values of x here, right? So if we're going to draw a mapping diagram, that is 0, 2, and 3. Look at this one. So for input of negative 3, we have 3 outputs here, which is 0, 2, and 3, which is not a function. Now, why the second graph is not a function or not a linear function? Because it's not a straight line. It's a function, it's the graph of a function, but it's not a linear function because it's not a straight line. So now how are we going to apply that function notation? So I have here f of x is equal to x plus 4. Then, if you're asked to find f of negative 2, f of negative 1, f of 0, f of 1, f of 2, it means that we're just going to substitute this negative 2, this x with negative 2, x with negative 1, x with 0, like that. Now, I'm going to show to you simply, very easy, just substitute. So f of negative 2 is equal to negative 2 instead of x plus 4. And f of negative 2 is equal to 2. Which means that the coordinate here is negative 2, 2. That's the point. Now, if I have f of negative 1, so f of 1 is equal to negative 1 plus 4, and that is equal to 1. Negative 1 plus 4 is 3. And then, if I have f of 0, it means 0 plus 4, and that is 4. And if I have f of 1, that is equal to, sorry about that, 5. So 1 plus 4, that is 5. And then if we have f of 2, that is equal to 2 plus 4, that is equal to 6. So now, it means that we have now different points. So negative 2, first point, negative 2, gonna repeat it here. And then y is 2. Next, negative 1, and then y is 3. Then we have, if x is 0, we have 4. Another one, if x is 1, and that is y is 5. And then if x is 2, then we have y is 6. So we can plot this on Cartesian plane to find out what the graph looks like. That's the graph. We're going to plot the points. It's a straight line. Okay? So if you're given table of values, how we're going to determine that that is for linear function? So let's find out. Let's say I have f of x is equal to 3x minus 5. Or I can rewrite that as y is equal to 3x minus 5. You know, y is equal to fx, right? So I am going to assign values for x, negative 2, negative 1, 0, 1, and 2. It means we're going to find f of negative 2 and substitute x as negative 2 here for this given. And that is equal to negative 6 minus 5, that is equal to negative 11. So f of x or y is equal to negative 11. F of negative 1, so 3 times negative 1 minus 5, that is negative 3 minus 5, and that is equal to negative 8. So f of 1, of f of negative 1, that is equal to negative 8. What about if f of 0? So 3 times 0, that is 0, minus 5, therefore f of 0 is equal to negative 5. And f of 1, that is 3 times 1 minus 5, that is 3 minus 5, that is equal to negative 2. And then we have f of 2, that is equal to 3 times 2, that is 6, minus 5, that is equal to 1. So now we have the values of f of x or y. Let's see what we can find it here. You notice the difference here is 1. Okay? We have negative 1 minus negative 2. The second one minus the first one, it becomes plus. So that is equal to 1. Negative 1 plus 2 means 1. So the difference here in x is 1. Okay? Now, check the difference here. So we have negative 8 minus negative 11, that is equal to 3. How about here? Negative 5 minus negative 8, that is also equal to 3 because this becomes plus here. Change the sign of the subtrahend and proceed to addition. So negative 5 plus 8 is 3. How about here? Negative 2 minus negative 5, change the sign of the subtrahend, so it becomes plus here. And that is negative 2 plus 5, that is equal to 3. And the last one, negative 1 plus 2 becomes, plus 2, yes, because change the sign of the subtrahend becomes addition. So 1 plus 2, that is equal to 3. So what have you noticed now if it's a linear function? If it's a linear function, it means that equal differences in x produces equal differences in y. That's a linear function. Again, in linear function, equal differences in x produces equal differences in y. So that's all for this video, and thank you for watching.